doing on Monday is we were talking about properties. And I just wanted to show you that not only do the properties apply to LOG types of problems, but they also apply to our natural logarithms, and natural logarithm is abbreviated with LN. And what we would have written had we filled in a blank of some sort is I would have had ln of u plus ln of v can condense down back into ln of uv. We multiply the two arguments because there's a plus in there. And the minus sign indicates the division. And then lastly, if there's an exponent on the u in this case, we can take that value and write it as a coefficient. And the properties are not exclusive to LOG type logarithms. They also apply to natural logarithms. And actually our first two example problems are really what we did on earlier this week. Just because we have breaks in between, I want to make sure that we don't forget everything that we were doing. And it's nice for people who were absent also. And this one kind of goes along with the homework problem that we were doing a little while ago. Because the first thing that I see on here is that we need to deal with this 1/2. Remember, when we have a coefficient of a logarithm, we're going to make that value an exponent. So if we rewrite this, it's going to be log base 6 of 25 to the 1/2 minus log base 6 of x equals log base 6 of 20. So I'm going to look at the property next, but you can figure out what 25 to the 1/2 power equals now. It's going to have to be done sometime. But before I figure it out, I want to apply the property. And what does minus tell us to do with the properties? We're going to divide. So we're going to take log base 6 of 25 to the 1/2 divided by x. And now we get log base 6 of 20. What we accomplish is we have log base 6 on the left, and we have log base 6 on the right. We want to get one logarithm on one side, one logarithm on the other side. Hopefully they're the same bases. And then we don't need to worry about log base 6 anymore. We need to worry about the 25 to the 1/2 power divided by x is 20. And again, some of you have already figured out that 25 to the 1/2 power equals 5. But if you don't remember how to do that, what we're going to do is we're going to take the square root of 25. The denominator of the fraction goes in the check mark part of the radical. We don't have to write the 2. So 25 to the 1/2 power is the square root of 25. And what does the square root of 25 equal? Equals 5. So we have 5 over x equals 20. And by the way, the answer is not 4 to this problem. Just in case you're thinking that it is, it's not. We're going to multiply both sides of the equation by x. You could also cross multiply. And we end up with 5 is 20x. And finally, it's 20 times x, so the inverse operation is to divide by 20. And then we end up with 1/4. So x equals 1/4, but we still need to check for extraneous solutions.
So we want x on the solution up there. And
So
1/4 is positive, so it's good.
when we go back in here, this is the part that we need to look at. 25 is already positive, 20 is already positive. This value needs to be positive, but 1/4 is positive. So 1/4 is our solution to our problem. And that's what we did earlier this week, and we're gonna continue on here. And we didn't exactly do a problem like this one. Did I flip over too fast? We didn't exactly do a problem like this. This one, yes. This one here. The only difference is that we have a natural log instead of a common log, so to speak. We had a different base there. A common log has base of 10. But this one is, in fact, an exact example from your book. And I seldom use examples from your book, but it was a better one than I could find other places. But it has a natural log. We're still going to look at it from the property perspective, and what does plus tell us to do? Tell us to multiply. So we're going to take x, and we're going to multiply by x minus 4. And now what we've done is that we have a natural log on the left side, and we have a natural log on the right side. So we have the same bases, but by the way, what is the base of natural log? Just in case you don't know, it is an e. It doesn't have to be written. By the way, also, you do have a button on your calculator. I don't have my calculator up right now. You do have a button on your calculator that says ln, it's off to the left, that you could use. And now what happens is we've got ln on the left, ln on the right. That's not going to help us to solve. We're looking for common bases, so we need to work with the part where we have a variable. The bases are already the same. We're going to distribute. We'll get x squared minus 4x equals x plus 6. And eventually we're going to have to factor on this problem, so let's move the x and the 6 over to the other side. And we get x squared minus 5x minus 6 equals 0. Be careful when you factor. We get x. Factors of 6 are 1 times 6 and 2 times 3.
1 times 6.
But we need to be careful here, because 6 minus 1 will give us 5, and -2 and -3 will give us 5. This will be 1 minus 6.
But that's like -2 times -3 equals positive 6.
-2 times -3 gives us positive 6 instead of -6. So we're going to have plus 1 minus 6. And again, I hope that you can tell me. X equals -1, x equals 6. If you can't, here's the work. X equals -1. Let's write that. X minus 6 equals 0, and we add 6 to both sides. X equals 6. We still need to check for extraneous solutions. So when we go back to the original equation, going back in here, this value has to be positive. This value has to be positive. This value has to be positive. And when we put the -1 back in, -1 is not positive. So our -1 is extraneous. Don't scribble it out so I can't read it. Because -1, it looks like a legitimate answer, and until we determine that it's not, that's part of the work that I'm looking for. When we go back and put 6 in, 6 is positive. 6 minus 4 is positive. 6 plus 6 is 12. Back in the original equation, those are all positive values. So our solution on this one is 6. And that's really what we did earlier this week in our notes, especially for those of you who are absent, or those of you who are watching this on a video. But now what we have is a little something different. We're still going to use properties. But what we have is we have logarithms on one side of the equation, and we don't have any logarithms on the other side. So our first part to deal with is, what does minus tell us to do? Well, it tells us that we can combine these by division. But we cannot get rid of the logarithm like we did. Like last problem, we crossed them out. Well, what we can do is we can go around the world. We can convert this logarithm from a logarithm to an exponential. And all that a logarithm is another way of writing an exponent. So this is 2 to the first equals x plus 2 divided by x minus 2. And it's nice that it's 2 to the first, because 2 to the first is 2. So the next thing that we're going to do is we're going to multiply this side by x minus 2 and multiply this side by x minus 2. You can look at it as cross multiplying. Those x minus 2's cancel out. So we have x minus 2 times 2 equals x plus 2. And now we're going to distribute. Too many 2's in this problem, but we end up with 2x minus 4 equals x plus 2. Did I mess up?
No, I'm just not quite sure I understand.
We have like bases.
So now we just need to solve for x. We're going to subtract x from both sides. We can add 4 to both sides. And we get x equals 6. And once we come up with our solution, we still need to go back and check for extraneous solutions. So eventually we'll get back up here to the beginning problem. And when we go back into this part of the logarithm, it needs to be positive. 6 plus 2 is 8. Positive number. 6 minus 2 is 4. Positive number. We get positives. You could type this in your calculator and check it as well. Remember that the button is alpha. Oh shoot. The button on to use the logarithms is we can go to alpha window number 5. That will allow us to type in our base. If you have an Inspire calculator, you have to type the base in every time you do the problem. So, alpha window on the calculator. But we did determine that 6 is a solution to our problem. Which leads us to problem number 4. Again, the difference today is that we have logarithms on one side of the equation, but we don't have them on the other. The properties still hold true. And in this case, we have plus, and what does plus tell us to do? It tells us to multiply. We get log base 4 of x plus 2 times x minus 4 equals 2. We have a logarithm on one side. we don't have a logarithm on the other side. So we have to have some method for getting rid of the logarithm, and that's going to be to go around the world. So this is 4 squared equals x plus 2 times x minus 4. We're going to have to FOIL. So it's 16 equals x squared minus 4x plus 2x minus 8. First outer inner last. If we combine the like terms here, we have x squared minus 2x minus 8 equals 16. If we move the 16 back over, we get 0 equals x squared minus 2x minus 24. And then we are going to factor. And remember, factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And we want the values to combine to be 2, so that it has to either add or subtract to be 2. In fact, it needs to be a negative 2. So we've got our 4 and our 6. And it's going to be minus 6 plus 4. And once again, I hope that you can tell me that the answer is x equals negative 4 and x equals 6. If you can't, x plus 4 equals 0. There's the x equals negative 4. X minus 6 equals 0. Get x equals 6. We still need to check for extraneous solutions. This part of the logarithm must be positive. And when we put in our first value of negative 4 plus 2 is negative. Not part of our domain. This is going to be extraneous. So let's hope that 6 is a solution, but by the way, you can have no solution to these problems. 6 doesn't have to be a solution. But 6 plus 2 is 8, which is positive. And 6 minus 4 is 2, it's also positive. So we do have a solution to this problem, and that is that it's x equals 6. So for those of you who have more experience with logarithms, the way that I'm going to solve it with properties isn't the only way to solve this problem. I like the properties, and I am looking at one particular issue, which is why I put this in as an example. But notice that we have log base 5s on the left side of the equation, and we don't have a logarithm on the right side. And that's what we have to watch out for. Do we have logarithms everywhere where we can simply ignore the logs, or do we have to apply the definition of logarithm to the problem? And this one's going to require us to apply the definition. But before we apply the definition, we should combine over here on the left side of the equation. We have a plus or an addition process, so we're going to multiply these. But just like the previous two, because we have a logarithm on the left and we don't have a logarithm on the right, we are going to go around the world. So when we convert, we get 5 to 0 equals 4x minus 1 times 2x. What does 5 to the 0 equal? 1. Over here we can distribute, and we get 8x squared minus 2x. And then to solve this, eventually we're going to have to factor. So we're going to have to move the 1 to the other side. So we get 0 equals 8x squared minus 2x minus 1. So the method that we use in this classroom is called slide divide. But some of you are used to doing split the middle. I'm showing slide divide right now, but some of you might need to split the middle. We're going to take this 8 and we're going to slide it over. When we slide it over, we get x squared minus 2x minus 8. A little bit easier to factor when there's no number in front of the x squared term. So we get x, and the factors of 8 that combine to be 2 are 4 and 2, with 4 being negative. But what we did is we slide the 8, so we can't ignore that. We have to deal with it, so we're going to divide these both by 8. And we're going to simplify these fractions. So we get x minus 1/2. And then we get x plus 1/4, and we simplify the fractions. And in fact, we can leave it in that form, but for those of you who did split the middle, at this point what you're going to end up with is you're going to end up with 2x minus 1. And what we can do is we can bring that 2 up and bring this 4 up. And now we can get our solutions, whether we get them from here or from here. These mean the same thing. The reason that I like this first one is that we can say x equals 1/2, x equals negative 1/4 right away for most people. Otherwise, we have to take 2x minus 1 and set it equal to 0. And then we add 1 to both sides. Get 2x 1, divide both sides by 2. X equals 1/2. And over here, 4x plus 1 equals 0. Subtract 1 from both sides. You get 4x equals negative 1, and divide both sides by 4. X equals negative 1/4. But however you ended up with that, in fact, you could have used the quadratic formula to solve that. We still need to go back into the original equation and check for extraneous solutions. So when we look back up here, what has to happen is this value has to be positive, and this value has to be positive. Well, our first solution was 1/2. Half of 4 is 2, and 2 minus 1 is 1, which is positive. Half of 2 is 1, positive. Negative 1/4, we get 4 times negative 1/4, which is negative 1, minus 1 is negative 2. So it turns out that our negative answer here is extraneous.
I feel like that's been the way with almost every problem that we've done.
That's good. So, the thing is, as people are catching up, sorry I went too fast, is the negative answers have a better chance of being extraneous, but they don't always have to be. Our solution can be negative. It's when we put that value back into the original equation that the value cannot be negative. We can also have positive numbers that are extraneous solutions also. Number 6.
Oh yeah, we were doing notes.
A little bit different here on this one, but not that much different. The thing is, on our previous examples, we've always had the logarithm on one side and not on the other. So what we're going to do is we're going to put the logarithms on the same side of the equation so we can apply our properties to that. So let's add log base 2 of x minus 7 to both sides. And we've got log base 2 of x minus 4 plus log base 2 of x minus 7 equals 2. Well, we've got the same base, so that's good. So what does plus tell us to do? We're going to multiply. So this is going to be log base 2 of x minus 4 times x minus 7 is 2. But what I want to say one more time, just to reinforce this, is if the logarithms are not on the same side of the equation, move things around so that they are.
Why can't we just use our bases?
So now we need to use the around the world again. We've got a logarithm on one side, but we don't have it on the other. And we end up with 2 squared equals x minus 4 times x minus 7, which is going to require us to FOIL. So we have 4 equals x squared minus 7x minus 4x plus 28. If we combine like terms, we've got 4 equals x squared minus 11x plus 28. And let's move the 4 over. So we have 0 equals x squared minus 11x plus 24. And we need a factor. So it's x and an x. Factors of 24. 1 times 24. 2 times 12. 3 times 8. 4 times 6. Will any of those combine, either add or subtract to be 11? Negative 3. And negative 8. So we're going to take each of our factors and set them equal to 0. And hopefully you can just simply say x equals 3 and x equals 8. But if I remember correctly, even though both of these answers are positive, I think that one of them is extraneous. So we need to really be careful and go back and check. We're going to go back into the original equation. And what has to happen here is that this value must be positive. This value must be positive. And our first answer is 3. Look what happens. 3 minus 4 is negative 1. The value here cannot be negative, which means that our 3 is extraneous. I do believe that 8 is a viable solution.
Yes.
8 minus 4 is 4. 4 is positive. 8 minus 7 is 1. 1 is positive. So x equals 8 for our solution there.
Well, for once, a positive number was extraneous, but it was still the smaller of the two numbers.
And I don't think that there's a pattern to that, but there could be. As we finish here, we've got some of the same issues on this one. But what I'm going to recommend that we start with first is this 2. This coefficient on the logarithm, remember, can be written as an exponent. So this becomes log base 2 of x minus 7 squared equals 6 minus log base 2 of 16. Well, just like example 6, we have a logarithm on the left side and we have a logarithm on the right side. We need the logarithms on the same side. So let's move log base 2 of 16 over to the other side. And we get log base 2 of x minus 7 squared plus log base 2 of 16 equals 6. We have like bases. We have a plus in there, and that's going to be our property. And our property, when we add two logarithms together with like bases, says that we can condense it down into multiplication. But we need some way to get rid of the logarithm. So one final time today, we're going to do around the world. And we end up with 2 to the 6th equals x minus 7 squared times 16. To the 6th, if you type it in your calculator or you figure it out, is 64. And the thing is, if we FOIL out x minus 7 squared, and then multiply it by 16, we're going to have some darn big numbers in there. And we don't want big numbers in there. So remember, this is x minus 7 squared times 16. Let's divide both sides by 16 and not have such big numbers. 64 divided by 16 is 4. And in fact, I'm not going to FOIL out this time. X minus 7 squared means x minus 7 times x minus 7. But the opposite operation of squaring something is square rooting. When square rooting and squaring cancel each other out, we get x minus 7 equals. Be careful over here on the other side, because not only is the square root of 4 2, it's plus or minus. That makes life a little bit simpler to solve, because we get 2 equals x minus 7, and negative 2 equals x minus 7. And then we can solve so that we end up with 9 equals x. And when we add 7 to both sides, we get x equals 5. And we need to check for extraneous solutions. We go back to the original equation. This value must be positive. That's the only place that we have to check. And our first solution was not. 9 minus 7 is 2. 2 is a positive number. Our other value, 5. 5 minus 7 is negative 2. So again, even though this was a positive answer here, when we put it back into the original equation, it gave us a negative value in the argument, and therefore we need to recognize it as an extraneous solution.